Okay. Hi guys, I got some questions and concerns about your upcoming MedCalc test. So I thought I would try to put together a study guide / tutorial on what you need to know how to do the math. I was going to do a workshop, but I'm out of town this week, and I know your guys' test is next week, so I figured this would be better, and you can keep coming back to it if you need to. So all of these questions on the practice test I made, I got straight from the Dosage Calculations book, so you can follow along with those. When we get into the later sections with the word problems, I did shorten them just for my own convenience on this page, so I would definitely recommend looking at the book itself if you have it to see kind of the whole word problem so that you can see how to dissect it out and get the information you really need. Right now we're starting on chapter 6 just for our conversions. These questions are from page 123. So these are the main conversions you're going to need to know. Just memorize these off bat. Kilograms especially, because once you get to pediatrics, your problems, your medication dosages are going to be weight-based. The worst thing I ever did, and Miss Ewing still teases me for this a year later, is I got my conversion backwards. So the entire test was wrong. That sucked. Don't do that. So, let's see. I like to do my conversions step by step. So going straight from like this first question, micrograms to grams. I tend to kind of lose my place trying to do the math like that. So I will go micrograms, 2 milligrams, 2 grams. But if you want to do it quickly, you just do multiply it by a million, multiply it by 1,000 2 times. Or if you can keep track of the decimal points to do it, that's probably the easiest way. I did trip myself up on that a couple times, but that would be, 230 micrograms. You're going to go 1, 2, 3. That's your first 1,000 to get to milligrams. So it'd be 0.23 milligrams, and then 1, 2, 3. That's your next 1,000. So 230 milligrams is going to equal 0.00023 grams, which is a ridiculous number that you're not ever going to use in the hospital, but it's good practice. Milligrams to micrograms, you're going to see that one a lot. So 5 milligrams. In order to get to go down, you're going to multiply by 1,000. To go up, you're going to divide by 1,000. Or you move your decimal point to the right, or you move it to the left. So here, for our 5 milligrams, we're going to go 5 times 1,000, or 5 times 1, 2, 3, 1,000. And we get 5,000 micrograms. And then for our micrograms to milligrams, like I said, we're just going to go the other way. I'm going to go 1, 2, 3. 4,000 micrograms equals 4 milligrams. And then it'll be the same thing for milligrams to grams. If you have 4,000 milligrams, you're going to have 4 grams. Coming down here to question 31, because those are all going to be the same, honestly. It's just practice your conversions, make sure you memorize them, life will be happy. Now, these next ones are in chapter 7, right? Nope, just kidding, chapter 6, the last one. This one is chapter 7 for the I-Nos. So for cups to mLs, we know that there's 240 mLs per cup. So the way the book tells you to do it is to use the dimensional analysis right off the bat. So we know that there is 240 mLs per 1 cup. And then we have 2 1/4 or 2.25 cups. And then this is just what we want. And so the way this works is you cross out your units that are repeating. Then you get 240 times 2.25 divided by 1. And then that's going to end up being 540 mLs. So that's the dimensional analysis way to do it. The way that I prefer to do it, like I said, I go step by step. So if I have 1 cup, I know that that equals 8 ounces. And then if I have a 1/4 cup, I know that that's going to be 2 ounces, because just divide 8 by 4. Then these are going to go and divide by 30, because I know there's 30 mLs per ounce. So that's going to be, what did I just do? Oh, duh, because it's 2 cups, not 1. So our 2 cups is actually going to be 16 ounces. There we go. 16 ounces, 2 ounces times 30 mils, so that's going to be 480. Oops, we're not dividing. 480, and then 60 mils, and then you add those together, and you get your 540 mils. Which clearly that took a lot more steps than the dimensional analysis way, which is why the school wants you to learn the DA. Also, I'm going to show you 2 different ways to do all of the math, the kind of easy shorthand way and the dimensional analysis way. The dimensional analysis is what the grading is going to be based off of, so learn it, live it, love it. It's going to be more accurate in the beginning for the easy problems, it doesn't matter, but once you start getting further into the program and the equations get harder, you really need to just commit to the dimensional analysis. That said, I will kind of default to the shorthand if I panic, because it's easy to remember, and dimensional analysis sometimes isn't. So it's also a good way to check your work if you're not sure, and please, for the love of God, always check your work, because it's going to be stupid mistakes you make that trip you up, and then you won't pass the test. Like my first med math exam, I'm pretty sure I had to take it twice because I messed up like the microgram conversion. So check your little ones. Next question. So 3 tablespoons to 3 mLs. Tablespoons. We can go up here and see 1 tablespoon is 15 mLs. So we'll just multiply by 15. And we'll get 45 mLs. Or, again, how the book will show you to do it is actually, in this case, it's pretty much the same thing. We have 15 mLs per 1 tablespoon, because the top number is what we want to get by the end. So this question is asking how many mLs we get. So our goal is on top, and then what we have, our tablespoons, is on the bottom. Then, because we want to cancel them out, you cross multiply. So tablespoon is on the bottom. Now we're going to put what we have on the top. Tablespoons over, just 1, x, whatever. And then same thing, it would be 45 divided by 1, because we have our tablespoons canceled out, which is just the same as 45. Well done. And then, coming down to our weight conversion, like I said, this is the most important one, because this is the easiest one to mess up. And sure enough, when I was doing this, I immediately messed it up. So it's, whoops. We want to go 8 kilograms to pounds, so there's 2.2 pounds per kilogram. 2.2 pounds per kilo. So when we're going kilo to pounds, we want to multiply, not divide. I started to divide, and then I was like, wait, my numbers are super wrong. So we're just going to go 8 times 2.2 is 17.6 pounds. If we wanted to know how many kilos, which is more often you're going to get the patient's weight in pounds and have to convert it to kilos. So like if you have a patient that weighs 150 pounds, you're going to divide it by 2.2 kilos and get whatever that number is. 68.1. So that would be your kilograms. Don't ever mess this up. Always triple check your weight, because that is the most tragic mistake to make. So now we're going to chapter 7, just for the I&Os, just one question on it real quick. This caused a lot of debate in my class because we kept getting conflicting answers on what counts as input, as far as, ice cream, popsicles, ice chips or ice cubes, yogurt, pudding, orange juice with or without the pulp. So, going based off the list that we got, officially, what counts as intake? Anything that is liquid at room temperature. So, this would be ice / ice cream, popsicles, all of your drinks, coffee, milk, orange juice. You do not do anything weird for the pulp. They told us that if there was pulp in it, it would be less, and there's not enough of it to actually make the volume change. So all of your fluids that are already fluids, that goes into your intake. The only one that's different is your ice. When you have ice chips, it's going to be half of the volume. So if you have, say, 2 cups of ice chips, you're going to calculate that as 1 cup of water. And it's not because water expands when you freeze it, it's because of the airspace. When you have a cup of ice, it's not completely full. There's tons of space in there. So you're just going to cut the volume in half and then treat it like regular water. But the ice cream, because it's in a solid container, if it says 4 ounces of ice cream, that patient ate 4 ounces of liquid. If it's, 2 ounces worth of popsicle, that's just what it is. So ice is the only one you change. So, that being said, let's come down here and look at what our patient ate for our shift. Also, unless it says otherwise, your I&O is always for one 12-hour shift. Now, intake, 1 cup of coffee, 6 ounces of milk, 2 cups of coffee, and then 2 ounces of Jell-O. Oh, I forgot. Jell-O also counts as a liquid because, if you've ever made Jell-O, you know that pretty much what you put in is what comes out. Like gelatin, it'll call it gelatin on your test, not Jell-O. And the book also calls it gelatin, but I put it Jell-O just so that you guys know it's the same exact thing. It's literally just solid water that's not frozen. The gelatin powder doesn't add any volume. And you'll learn later that, like, people who have issues swallowing, you can thicken their water with something kind of like gelatin, or with elderly patients. If they forget to drink, getting them to eat Jell-O is actually a good way to keep them hydrated. Anyway, half a cup of water, and then, ounces. That should be 4 ounces of ice cream, sorry. So those are all of our numbers for intake. And then for our output, that's always going to be in mLs, because if they're recording outtake or output, it's going to be usually like with a Foley or with your different surgical drains, things like that, it's going to be in mLs. So that's the easy one. This patient had 50 mLs, 280, 480, and 360. So let's start with our intake. Again, I prefer step-by-step conversions. So we have 1 cup of coffee, 6 ounces of milk, another 2 cups of coffee, 2 ounces of Jell-O, whoops, half a cup of water, and then 4 ounces of ice cream. No ice in this one. So I am starting with cups, so the next conversion down is going to be our ounces. So 8 ounces here, the 6 ounces is the same. 16 ounces, because now this time it's 2 cups. 2 ounces stay the same. Half a cup is going to be 4 ounces. And then 4 ounces. And then you can either go across and like multiply by 30 the whole way down, or you can just add those up here and multiply it by 30 once. It's up to you. I did not make this easy on myself for my notes, so we're just going to go how I actually did it. 240 mLs, 180, 480, 60, 120, 120. So times 30 mLs for that column. And then our total is going to be 120 mLs. So our patient had 120 mLs of fluid. And then, like I said, output is going to be super easy. We're just going to add up all of those numbers, no conversions needed. So 50, 280, 480, 360, and our total is 1360. So I will put those, I'll just put those over here so we keep the numbers handy. 120, 360. Now let's start playing around with these numbers a little bit, because I realized after I did this that your questions on the test are going to be more complicated than this. So, what about your patient is getting IV fluids? Let's say 75 mils per hour of maintenance fluids. So that's going to be easy. That's just going to be 75 times 12. So they're getting 900 mLs per shift, which we'll add to that number in a minute. Now let's say that they're also getting 100 milligrams of, I don't know, an antibiotic that's available in 200 ml bags, and they're getting it Q6 hours. So again, we only care about the 12-hour shift, not the 24, so we're just going to multiply this by 2, because 6 goes into a 12-hour shift twice. So it's going to be 200 mLs times 2 administrations equals 400 mLs per shift, which we will also add to that number. So these together, it's 1300. Our new total why is that? Always keep your numbers straight, guys, because mine are not. Looking at my notes like, what did I write? 75 times 12. Yeah, that's not 100. Okay. Weird. For some reason I got 1485 for the intake. Anyway, so the new intake is going to be 1500, right? 1500 in the shift is our new intake. Now, what if our patient has some surgical drains? Let's say they have 2 JP drains. JP number 1, when you drained it throughout the day, the first one was 100, then it was 50, and then it was 25. Your second drain throughout the day, it's doing a little better. You got 75, 25, and 10. So that's 175 mLs total, 110 mLs total. So we're going to add that number up to our initial output, and the patient is going to have, let me just double check my numbers, 260. Okay, and so our new shift total is going to be 1645. And then I don't know if they'll ask you fluid balance on this one. They might. So in this case, you're going to take your daily output, so the 1645 minus your input, 1500, and that's going to be 145. So in this case, the patient is negative 145 mLs for the day. So at least they're not fluid overloaded. In general, anything you put into the patient, we want to see it come back out. So this isn't bad. Might be a little bit dehydrated, but that's probably fine. Okay. Now let's go down to our actual medication math. Yay! This is why we're really here. So starting with chapter 11, oral dosages. What page? Page 213. So like I said, there are full word questions for all of these, and I shortened them down. I also didn't include the actual medication names because it's not important. You shouldn't be memorizing your dosages off of your practice tests. They're accurate, but don't do it. So these also in the book have medication labels. I did not have the time, energy, care in general to try to upload those into my PDF here. So again, if you have the book, look at it because you do need to learn how to read your labels, and I'm sure you're going to get questions on this test with medication labels that you're going to have to interpret. But for the purposes here, what I like to do is first off find what's important. So what is your order? 2 milligrams twice a day. So what does that mean? That just means that'll also be shown as BID. Then we also want to know how the medication is available. So we know it's available as 1 milligram per capsule. And then what are we looking for? Capsules per dose. So the way I like to break down my questions is I will write the order in my availability, because this is how I'm going to then do my math. Because again, we're not getting to the dimensional analysis yet. You don't need it yet. So if our order is for 2 milligrams, we don't care how we are giving it. The route does not matter. And here we actually also don't care how often we're giving it, because the question is asking for our dose, not for our daily. So 2 milligrams, and it's 1 milligram per capsule. My preferred way is desire over have times quantity. So desire, have, or available times quantity. which, as you can see, we are already divided. Our desire is our order. We want to have 2 milligrams. We have 1 milligram in 1 capsule. So 2 divided by 1 is 2, times 1 is 2. There we go. Our answer is 2 caps per dose. Always remember your units. They're not going to accept it if you just put a number, and if you put the wrong unit, even if the number's right, you'll get your question wrong. So coming down here, 30 milligrams. We don't care about route, we don't care about time. And it's available as 20 milligrams per 5 mLs. And then how many mLs will we give per dose? Order 30 milligrams. Available 20 milligrams per 5 mLs. So 30 divided by 20 times 5 is going to be 7.5 mLs per dose. This one I just put in here because, again, it might trip you up because it's going to seem like our numbers are going to change a lot, but it's still going to be the exact same formula. So if the doctor is ordering 0.2 milligrams twice a day for 4 days, cool. We do not care how often for either of these. So our first one, it's going to be 0.2 milligrams. A couple days are going to pass, and we're going to lower the dose to 0.15 milligrams. And the availability is not going to change. So really, we're going to do the same problem twice. So it's going to be 0.2 milligrams divided by 0.05 milligrams. And we know it's 5 milligrams per tablet. So honestly, you don't even have to do the quantity here. You can just do what you want by what you have. So 0.2 divided by 0.05 is going to be 4 tabs. So we can have 4 tabs per dose for the first 4 days. And then to get for day 5, you're just going to go 0.15 divided by 0.05, and you're going to get 3 tabs. And that's it. Now, same thing. The doctor orders 500 milligrams, Q12, so you're going to give that once a shift for 10 days. So this patient is going to be getting their medication twice every 24 hours, once on day shift, once on night shift. It's available as 250 milligrams per tablet. How many are we giving per dose? 500 milligrams divided by 250 milligrams times 1 tablet. And that's going to equal 2 tabs. Okay, so now that hopefully we've got a handle on how to do just our basic med calc, let's start throwing in some more conversions. So first, we have 1.5 milligrams, and it's available as 0.5 milligrams per 5 mLs. So we're going to do exactly what we did on the other questions, but then we're going to convert it to ounces. I don't think the ounces was in the book. I think I just added that for fun to start showing you guys how we'll use the dimensional analysis. So first, we have 1.5 milligrams ordered. It's available as 0.5 milligrams per 5 ml quantity. So now that this number is different over here, we're not just going to multiply by 1. So now you can see you cancel out the conversions that are the same. It's like dividing a number by itself. So we no longer care about the milligrams because we're going for mLs. How many mLs will you give? So 1.5 divided by 0.5 times 5 is going to be 15 mLs per dose. Now we want to convert it to ounces. And we know back from the top that there are 30 mLs per ounce. So we're going to divide 15 by 30 and get 0.5 ounces. So that's kind of the, I don't know if it's the easier way, but it's easier for me. So that's kind of the algebra way to do that question. The dimensional analysis way to get that conversion to ounces, we're going to do it like this. We have 1.5 milligrams per dose. We're going to multiply it by 5 mLs because that's what we have available. 5 mLs over 0.5 milligrams. Because when we have a unit up here, we want to cancel it out down here. So now the milligrams are gone, but we still need our ounces. So we keep going across the train tracks. So now we have mLs, so we cannot put mLs on the top here. So instead of putting the 30 mLs, we're going to put 1 ounce, which is 30 mLs. Now our mLs cancel each other out, and we want ounces per dose. Well, the only units we have left are ounces and dose. So you just multiply it across, and you end up with the exact same math problem essentially. 1.5 times 5 divided 0.5 times 30. Yeah, and then it's going to end up being 7.5 divided by 15, which will be the 0.5 ounces per dose. And that's it. That's your first kind of how to do dimensional analysis. And then if you were doing it, mils to teaspoons or to tablespoons, it would be the same thing. You would just put tablespoons or teaspoons instead of ounces. So now let's go to 54. Which is on page 226. I think I also changed this one up a little bit, so if it looks different, that's why. So let's go through the problem. Our order is for 30 milligrams. It's available as 10 milligrams per 5 ml syrup. Oh, here we go, because we're giving teaspoons per dose this time. So think of this like a cough syrup. So we want 30 milligrams in our dose. We have 5 mLs, which will give us 10 milligrams, because remember, we want to cancel our milligrams out. And now we want to get to our teaspoons. So we know 1 teaspoon will give us 5 mLs. Now our mLs cancel out. And now I multiply across. So that's going to come out to 150 over 50, which is then going to give us 3 teaspoons. per dose, because we always want to put our units. And there we go. So now we're going to chapter 12. This is where the fun math starts. Let's see what page. Chapter 12, page 297. And so again, these have medication labels that you're going to want to look at and learn how to read them. But just for the sake of time, I will skip that. So now, we're just going to keep doing what we've been doing, just because the route has changed. We're now doing, intramuscular or IV instead of oral meds. The math is the same. Order is for 500 milligrams. Availability is 1 gram for 2.5 mLs. How many mLs will we give? Except this time, we get to go milligrams to grams. So again, you can either do this as desire over half times quantity, which is 500 milligrams divided by 1,000 milligrams, because we know there's 1,000 milligrams per gram. Multiply that by 2.5 mLs, because that's our availability. The milligrams cancel out. And then that is going to equal 1.25. Once you do all of the calculating, 1.25 mLs per dose. But because we are converting, we can use dimensional analysis for this. So let me erase all of that. Okay, here we go. So start with what we have, because we're really just trying to plug in all the information we know so that we can solve for what we don't. 500 milligrams per dose. We have 1 gram, which we know is 1,000 milligrams. And then we have our mLs, 2.5 mLs. It's 1 gram. Because when you start to do this, usually the number you have on top will be the same as the one you have on bottom, because this is your conversion and this is your availability. So now we just solve across. So we get 1 to 50. Oh, because again, milligrams are gone, grams are gone. We're left with mLs and dose, which is what our question is asking us. Oops. So we have 1,250 divided by 1,000. And it's going to be 1.25 ml per dose. There we go. Okay, next one. We have 110 micrograms. It's available as 500 micrograms in 2 mLs. How many mLs will we give? There's no conversion that needs to happen here, so we can just do the question. 110 micrograms divided by 500 micrograms. We're going to get a fraction, but we're canceling those out. Multiplying it by 2 mLs, because that's our availability. And we're going to get 0.44 mLs per dose. If this was a pill, that would be a horrible order, because how are you going to get 0.44 of a pill? You can cut a pill in half pretty easy. You can even get it into a quarter if you really have to. But when it comes to liquid measurements, you can do 0.44 no problem, So that's an acceptable number. Next, we have 10 milligrams. available as 5 milligrams per ml. How many mLs are we drawing up? When it's divided, when it's just X amount of milligrams per 1 ml, you don't, like I said, you don't have to do the whole thing because it's just going to be this number times 1, or divided by that number times 1. So, like 10 divided by 5 is 2 mLs. That's our answer. We're done. Or you could do 10, 5 times 1, and then still get it. It's up to you. But when it's a super easy number like this, you can just do it quickly. Okay, on to question 22. So we're skipping ahead to page 302. Wait, 22? Yeah, page 22. 302, question 22. My notes are written wrong. Okay. 400 milligrams. Available as 500 milligrams in 2 mLs. Same thing we've been doing. We want 400 milligrams. We have 500 milligrams. This time we're multiplying it by 2 mLs. And that's going to come out to 1.6 mLs per dose. Okay, last two for this chapter. These are the fun ones. So going now to page 305. So this question has a lot of information on it. What do we actually care about? Well, first of all, let's see. 200. So we have D5W, 250 mLs, and we are adding sodium chloride to it. 7.5 MEQs at 2 mils IV per hour. It is available as 40 mLs containing 2.5 MEQs per ml. How many mLs are we adding to the D5W? Well, first of all, we don't care about the D5W at all. Because we're adding to it, we're not doing anything. We're not changing that number. We want to know how much of the sodium chloride we're going to add in. We also don't care about the 2 mils per hour. We purely want to know how much medication we are adding to our fluid. And then finally, this is our total, not our availability. We don't care about that either. We care about this number right here. This is our concentration. That's our real availability. So we know that we want, this is our order, we want 7.5 MEQs, which is like saying milligrams. Electrolytes are measured in MEQs. We want 7.5. We have 2.5 in our concentration per 1 ml. And our answer, once we do that, is going to be 3 mLs added to the 250. So the total fluid volume is going to be 250 mLs, but that is not what the question is asking. So ignore all the fluff. It's a distraction. Okay. Next question. Again, same thing. We want 15 milligrams. We have 25 milligrams per ml. 15 divided by 25 times 1 ml is going to be 0.6 mLs. Now let's say the question was how many are we going to give per shift? So If we know it's Q6 hours, we know we're going to do that twice a shift. So we're going to give 1.2 mLs total per shift. If we want to know per day in a 24-hour period, we would multiply that by 4, or this number by 2. So it would be 2.4 mLs per day. Okay, now we're going to chapter 14, reconstitution. If they did a workshop and got to this point, I'm sure this is where most of you wanted to cry. Reconstitution sucks, I'll be honest. So let's see what chapter 14. We're going to page 415 now. There are a lot more questions to answer in the book than I have here, and that's because half of them come from the medication label that's attached to it. Like, it's going to ask you how many, what's it called? How many milligrams and dose is in the entire bottle once you reconstitute. You could do the math for it, but honestly, it says it on the label in the tiny print, so you can just find that. Most importantly, we need to figure out how much diluent we need to add and how many mLs we need to give. So we want 250 milligrams per dose. We don't care about the route or how many times we're giving it. In order to reconstitute the medication, we're going to add 90 mLs of water. We don't care that it's in 2 portions. It just wants 45, shake it, 45 again. But the total, we want 90. And then our concentration, every 5 mLs will contain 125 milligrams. So it's 125 milligrams per 5 mLs. Again, how much diluent you add, it's just the straight 90 mLs. It's right there on the label. You'll be fine with that part. How many mLs do we give? Same math we've been doing the whole time. We want 250. After we reconstitute, we have 125 per 5 mLs. And that is going to come out to 10 mils per dose. Okay, same thing again. 275. We don't care that it's PO. We don't care that we're giving it Q6 hours. This time you're going to add 36 mLs of water, like sterile water usually, in 2 portions. Again, we don't care that it's 2 portions, and honestly in the hospital you're not going to do that. You're just going to put the whole 36 and shake. And then our concentration is going to be 125 per 5. So this is honestly almost the exact same problem. We're going to give 36 mLs of diluent. We want to get 275 milligrams by the end. Our concentration is 125 milligrams per 5 mLs. Our answer is going to be 11 mLs per dose. Now we're getting down to the units and the very large numbers, because units are always in tens or hundreds of thousands. So let's see, question 6. We're just going to the next page. So our order is for 250,000 units. My advice to you, write out the entire number. Don't try to put like 250K or anything like that. You're going to end up losing your zeros and then you'll get a weird number. And for this question, the medication label in the book, it has a neat little chart for how many mLs you add and how many units per ml you'll have after it's added. So I wrote it out here just for simplicity's sake. So if you put 18.2 mils of water, you're going to get 250,000 units, which that sounds a whole lot like our order, right? except when you finish the question, how many mLs will you get if you give 8.2 mils? So this, right off the bat, is not our answer. But if you put 18.2 mils, you're going to get 500,000 units per mil, which is not our question. So this isn't the answer. And then if you put 3.2, you get 1 million. We don't care about that. Not important. So the question is asking, we're going to put 18.2, and we want to get 250. So how are we doing this? We are putting our order at the top, like we've been doing, 250 units. And we know that if we put 8.2 mils, like the question wants, we're going to get 500,000. So we're going to divide our order by 500,000 units. And then we're going to get, and then it's just times 1 ml, so you can add that. And then we're going to get 0.5 mLs per dose. So yeah, at the end, just remember what the question is asking. We want to know how many mLs will you give if 8.2 mLs are added. So you just divide your order by your availability. Okay, last one for this section. The doctor orders 500 milligrams. You're going to add 60 mLs, and then you're going to get 200 milligrams per 5 mLs, or 4 grams per bottle. So remember, 200 milligrams per ml is our concentration. We're going to add the 60 mLs, no problem. This already we know is going to be 200 milligrams per 5 mLs is our concentration before we've even done any math. So we've answered 2 out of 3 questions. Then we're going to ignore the 60 because we don't care about it anymore. And we're going to divide the 500 by the 200, multiplying it by the 5 mLs we have available. And then we're going to get 12.5 mLs. 12.5 mLs per dose. And we're done. The last part is going to be our IV flow rates. So that's where we get like our drop factor, our GTTs. Mostly you're going to be doing mLs per minute or mLs per hour, but your drop factor is per minute. So you're going to have to know how to go back and forth. And again, this is where you'll start using the DA for real. So let's see. We want 500 mLs. We want to infuse it over 24 hours. So how many mLs per hour are we going to get? So this time we do care about our time as far as our administrations, because we're not giving this once in 24 hours. We're giving it across 24 hours. So the simplest way to do this is just going to be your 500 mLs divided by 24 hours. And that's going to give us 20.8. And you're just going to round up to 21. So we're going to do 21 mLs per hour in this case. Okay, next we have we want 40 milligrams IV Q8 hours. So do you guys think that is important? Let's finish the question. The medication is dissolved in 100 mLs of normal saline and is to be infused over 1 hour. And our question is asking us how many mils per hour. So to answer my question, nope, doesn't matter. Because this 400 milligrams is not a volume. It's a dosing, and this question is asking for our volume. So we're going to divide 100 mils by 1 hour, which, you guessed it, is just going to be 100 mils per hour. So that 400 milligrams, that's just there to distract you and get you thinking about the wrong numbers. Don't fall for it. Now we'll do our drop factor, and I actually really like these. I think they're fun. So if we have 800 milligrams Q12, so they're getting this medication one time on your shift. It's dissolved in 100 mLs of D5W, so that's our volume, and we want to infuse it across 30 minutes. Our drop factor, and the questions are always going to give you your drop factor, is 15 drops per minute, drops per ml. How many drops per minute are we going to give? So once again, we don't care about that number at all. We want our volume, our time, and our drops. Okay, so now for the dimensional analysis method. What we want is drops per minute. So we're going to start here because that is what our question is asking us. So we're going to put our drop factor on top because this just goes straight over. You're not cross multiplying this part yet. So we have 15 drops because we know that. And 15 drops gives us 1 ml. So next we want to get our mLs. We know we have 100 mLs. And we want to give it over 30 minutes. So let's look at our conversions. We have our mLs cancel out. We have our drops at the top and our minutes at the bottom. That means we're done. Once these two units are where we want them over here, then we know it's time to solve. So that's going to give us 1500 over 30, which is then going to give us 50 drops per minute. Okay, let's go down to the next one. 137. Did I tell you guys what page we're on with too? Yeah, sorry. So we're on page 453, 454 now. So we have 4 million units in 100 mLs of D5, Q12 hours. So once a shift, we're going to put 100 mLs into this patient, and it's going to get them 4 million units of their medication. Our drop factor is 10 drops per mil. We want to give the medication over 60 minutes. How many drops per minute should be given? So again, we don't care about the dose. We don't care about the frequency. We want the volume. So we're going to go ahead and put our 100 mLs. Wait. Let me do what I said I would do in the last one. So we want our drops, and we want our minutes. So we have 10 drops per 1 ml. We have ml on the bottom, which means we need to put ml on the top. We have 100 mLs. And we know we want to give it over 60 minutes. So that's just going to be 1,000 divided by 60, and that's going to be 16.6. Drops, you cannot fraction a drop, so we're going to round that up to 17 GGT per minute. If it was mLs, you can have, 0.6, 0.4, whatever. But for drops, it always needs to be a whole number. Okay, last two. We have an order for 1 gram, Q8 hours. The medication is dissolved in 50 mL, infused over 30 minutes. Our drop factor is 60. How many drops per minute do we want? We want our drops per minute. We know we have 60 drops per 1 ml. We don't care about our grams, but we do care about that 50 mLs. And we have now plugged in that one. We have plugged in that one. All that's left is our 30 minutes. So we put that on the bottom. Do we have our GTT? Yes, we do. Whoops, that's not supposed to be crossed out. We cross out our mLs. We make sure our GTT is on top and our minute is on the bottom. We solve. And we end up with, how many is this? 3,000 divided by 30 equals 100 GTT per minute. Also, I'm here to tell you, I have never once had to do this in the hospital. There's been a couple times where I have had to math out my mLs in my reconstitutions. I have never once actually calculated the drops per minute in the way you do it in the hospital to make sure it's accurate, because you don't have a pump. That's the whole point. This is for gravity infusions. You get a stopwatch and you look at your IV tubing as it drips and you count it for a full minute, and you just twist up and down the dial until you have what you want. I'm here to tell you, you'll do that like in the ER, and you might do it in the WIP because they give fluid boluses a lot over there in triage. The nurse is going to tell you give it wide open, in which case you open it all the way. They might tell you give it slowly, open it halfway. But they're not going to tell you, like, I want exactly 17 drops per minute. Nobody has time for that. Okay, our last question. And if you guys have actually stuck it out for the whole hour, I am so proud of you. And you're totally going to kill it on this test. So, we have 5 milligrams per hour. Our concentration is 200 milligrams in 250. How many mils per hour are we going to set the pump? Let me see. So now that we're back to easy math, we can just do desire over half times quantity. We know that we want 5 milligrams. We want it across an hour. We know that we have 250 mLs available with a total of 200 milligrams. We can cross out our milligrams. And we keep our mLs per hour because that's what the question wants. We're going to get 1250 divided by 200. And that equals 5.25. And I think the book actually rounds this one up to 6, honestly. Let me see. It doesn't round it up to 6. I think I wrote it wrong. Hold on. 250 divided by 200 times 5 over 1. Oh yeah, wrote it wrong. It equals 6.3. And we're just going to go ahead and round that down to 6 mLs per hour. Which the question will tell you if you're rounding it to the nearest tenth or if you're rounding it to a whole number or what. So just pay attention to what your question says. And yeah, that's it. If you guys have any questions, if there's anything I didn't cover, I know you have OB this semester. I took it with pediatrics, so my medication exam was based mostly on pediatrics, and we didn't really have a specific test for OB, I don't think, so I don't know if they've told you the math is going to be different. If there's anything that they add in that I didn't cover here, just let me know. And yeah, I can do another video, or I can make like a cheat sheet for you guys, but for the most part, this should cover it. And yeah, if you have any questions, feel free to email me, text me, drop a comment on the post. I'm trying to keep an eye on those. I am always available if you guys want to do like meet up and study, or if you want to do online like review sessions. I'm making review slides for myself I can give to you guys. Yeah, whatever you need, let me know. I'm here to help. And good luck on your test.